Alright, another draft physics presentation. Anyway, Daftloday has made a video. I'll play it and quickly. And I've already been over these three subjects before. He's playing some sort of like I got you with his experts, and nothing said in any of the videos he links to contradicts anything I have said or disproves it in any way. I just don't understand this argument from somebody else that's not specific or just doesn't have anything to do with what I'm arguing. Somehow he thinks he's demonstrating some sort of evidence or proof, and it doesn't exist as evidence or proof.
Okay, two from the greatest hits collection of 60 symbols. First, I'll have you note that mass is not what you think it is from high school. It's not the amount of stuff. What it is rather a strange numerical concept.
Okay, the video he links to that doesn't say that at all, so it clearly connects mass with gravity, and the fact that gravity is a very good detector of mass. But again, it doesn't do anything to dispute my theory, which explains actually why things have mass, where their theory doesn't. Their video leaves the question open. They don't really have an answer, and yet he's providing that as some sort of evidence of, see, it's different than you think. Well, the difference is they don't have an answer. But, you know, I'll play the videos.
Can measure, and that is rather fungible as a concept. So when LIGO gravitational detector says,
so he's still going to argue that somehow I've misquoted the LIGO people. They didn't really mean that 3 solar masses were turned into energy, even though they often explicitly, I can have quotes provided of them explicitly saying that, using even words like radiation. 3 solar masses worth of radiation. So in spite of what they say, in spite of what all the documentation indicates, he keeps arguing that no, it's not really energy. Yeah, it really is energy, and it's the only way they could make it work, as I've pointed out. There's no way we could detect what's happening 5 billion light years away unless it was a massive energy event. I mean, if you're detecting it with gravity waves aren't photons of light. To detect a difference in gravity, you need a huge difference in energy.
3 solar masses are converted. That doesn't mean that it's the amount of stuff.
So again, he's playing this game as if somehow they're not saying exactly not what he's saying. So he's going to reinterpret them and make an argument without a quote from the LIGO people, demonstrating that they don't intend to say it was a massive amount of energy when it was a massive amount of energy.
Secondly, 60 symbols video on polarization. What you'll see.
Okay, now I've done the other video on polarization. I guess I'll make some effort to link to it. You know, the Veritasium I think it was, or one of those guys. I did a whole video on this subject where they thought there was some paradox because of this idea that you can put this third piece of film in between and turn it at a 45-degree angle, and somehow it breaks logic. That's a paradox needing explanation, and there's no paradox. I already explained that it's because the filters aren't just filters, they're converters. They're actually changing the polarization of the light that goes through the filters. They're not just filtering. So the argument's already been made. This will be exactly the same argument the 60 symbols people make. So again, this fake contention that somehow those physicists have physics that's different than my physics. No, they're just using a different word, okay? He talks about waves. It doesn't have anything to do with fucking waves of light. It just has to do with the fact that the light is changed by passing through the filter.
Portrayed is polarization working through a plane, okay? A plane sheet, and then 2 sheets blocking out more light. Now then, the interposing of a 3rd sheet between these lights, well, let's say it breaks the simple analogy of the shape.
Okay, nowhere in the 60 symbols video does it describe any of this breaking this simple idea that polarization has something to do with maybe geometry. Nothing like that was indicated. And again, their explanation is essentially the same as my explanation, which is the extra filter, all the filters are essentially converting, not just filtering, they're converting any light that's within 45 degrees, that is 22 degrees on either side of the filter's polarization. They're accepting that light and converting it to straight. So anything that comes in this way, converted. Anything this way, converted. Anything this way, converted. Anything this way, converted. It's that simple, and that's exactly their explanation. So again, another completely false, fake, phony idea that somehow he's got me on a fact and these super scientists say so when they're saying exactly the same thing I said in my damn video.
Of light polarizing, okay? Because if it was so simple as that this sheet blocks this shape light and the other sheet blocks this
like I said, that's not my argument. So again, he's pretending I made that argument. I've never said it was that simple. I said exactly the opposite. I said so in the previous video on the subject. I pointed out the filters aren't just blocking, the filters are converting. I said it explicitly. I did these analogies. I pointed out the 22 degrees on either side. What more can I do? So, and what more of an asshole is this for saying I didn't say that when I did say that? To say my theory says it's just a filter when my theory clearly says it's a converter also. It filters and converts. I said that to Piro 2 years ago.
The opposite shape light, the interposing wouldn't do what it does. And furthermore,
so again, he's wrongly premised my argument, wrongly premised my theory, wrongly described it, falsely described it, and he's done so overtly over my explicit objections, and he just keeps doing it. He just keeps lying about my theory so he can argue it. Instead of telling the truth about what I have said, instead of quoting me, which he won't do, he instead perverts what I've said into some simplistic jargon that has nothing to do with the actual argument actually made. It's just lying for the sake of making some cheap buffoon video.
Let's call it, suggest to yourself, think about it.
No, you think about what an asshole you're being. On every one of these subjects, I've made an explicit point that is completely consistent with what these physicists say in the videos you're going to link to. Exactly the same fucking thing they argue. And yet you're pretending they're instructing me. Wrong. Wrong answer. Fake, phony, false.
The rattling about theory, yeah?
No, I have no rattling about theory. The theory was the thing that makes soot and a diamond, it's exactly the same atom. The exact same atom is a different it functions differently. Clear diamond, completely opaque soot. The thing that makes the difference is the geometry of the arrangement of the atoms. Exactly what I have said. Exactly. I've used exactly this analogy of a fucking diamond and carbon as an example. It's not rattling about. It's being transferred through an explicit geometry. The geometry, I've talked about how, light travels billions of years through the universe. It doesn't make any mistakes. There's no error code. It's an explicit geometry. No rattling about.
That there's some kind of strange change from the shapeness of light, but you can explain.
No, there's no strange change from the shapeness of light. Now, how can you even make any sense of that? Of course, it's nothing I've said. Okay, the light comes out. It accurately transmits the image because of the fact of the explicit geometry. And if you scrape up the glass, then you scrape off that explicit geometry, and that creates a hazy image.
It by the light rattling about.
So again, rattling about, never my rhetoric. I've talked about ricochet rabbit. I've used analogies that's why the light is slower. So I've used generalizations to say, look, this is the simple way of understanding it. The light doesn't go a straight line through the glass. That's why it's traveling a longer distance. I never said it rattles about. I've explained that it's basically being reflected by the electrons and the protons, okay, deflected into new directions, and that there's explicit geometry, and that's why it works. That's why what goes in ends up coming out the other end, is because the geometry of the arrangement of the protons and the electrons is explicit.
I don't have time to explain here and now, but essentially the rattling about theory doesn't hold water.
Okay, so this video about the rattling about theory, total internal reflection, has absolutely nothing to do with the subject of how the speed of light through glass. It has to do with a prism, and then they make one out of for a radar gun. And again, the explanation doesn't explain anything. There's no, their physics doesn't have an answer to the question. So again, there's nothing here. There's no got you. There's no counter argument, and all of this buffoonery. He does all this bullshit as if he's making an argument that has substance. There's no substance here. So let's play these stupid videos. So let's do the polarization first.
Now, Brady, this is the
Make sure this shows up.
which I'm going to enjoy.
I don't know who Brady is, but he's going to do in Brady's head.
Polarized by sheets of Polaroid. This is a sheet of Polaroid. It's polyvinyl alcohol with iodine thrown in it. So in here, I'm not sure which way round it is, there are long molecules which are stretched out, and they conduct along this direction, but they don't conduct that way. So that's what your Polaroid sunglasses are made of, stuff like this, which is built into it. So it reduces the glare, for example, off the road when you're driving along. So I put a sheet of Polaroid on top of this overhead projector, which produces light, and I put another sheet on top, polarized the same way, and they absorb a bit of light for each direction. But if I turn this top one round, so that it is actually perpendicular to that original direction, you can see that you can kill off most of the light. So there's some turning backwards, and that's gone all the way around.
Alright, so he's just taken two films, turned them opposite directions. One of them has the filter going this way, one has the filter going this way. Turn them this way, they block all the light, because one filter is blocking all the light going this way, and the other filter is blocking all the light going this way. So again, it's more, it doesn't just take one line, it takes everything 22 degrees this way, 22 degrees this way. The other one's going 22 degrees this way, 22 degrees this way. And you can figure that out. It completes the 180 degrees. You don't do 360 degrees because this is the same as this. Okay, so light going this way is the same as light going this way. So it's 180 degrees made out of 45 degree increments or sections.
And now I'm going back again, and you can see that it disappears. This is an offcut, a bit chopped off from the bottom of this to make it a square. And I can put it on top of these two, let me square them up, and you can't see it at all.
Okay, so he's got them now in the position where they're both blocking, they're blocking all the light. So obviously, whether he puts the new one in front or behind, it isn't going to matter because he's blocking all the light. So this part is an obvious, oh yes, of course that won't change the filter. The filter already blocked all the light, so there's no light for you to change.
I can put it underneath these two, and you still can't see it. But if I now slide it in between, you can see it.
Okay, so now he's going to put it in between the two filters. So the two filters are blocking everything. And what's the third filter going to do when you put it in between? Well, what it's going to do is it's going to say to the filter that's blocking the ones coming this way, this filter at a 45 degree angle is now going to take lines that are going, like I said, that were going this way, anything this way, and now it's going to take those and accept 22 degrees of them. And it's going to bend those this way. So now they'll be receptive. It'll take that 22 degree angle and turn it 45 degrees, which is halfway, which means the other filter will see it as 22 degrees. So you can just think of it as, what it basically does is it takes an angle that was 90 degrees difference, and now it converts it so they're only 45 degrees out of difference. And the 45 degrees means 22 degrees on each side, which means now you'll get half the light through.
Rolling this up in the bottom corner and sliding it in between.
Now just watch this.
You see,
Watch how quickly it goes from bright to dark. Okay? as he turns the filter, it doesn't take much of a turn at all before it goes dark.
See it? If I turn it around this way, it disappears. If I turn it around to 45 degrees, you can see something quite strong. And then turn it around.
See, it doesn't take much of a turn, and then you're already wiped out that 22 degrees. So as soon as you turn that filter 22 degrees, you've wiped out any benefit it was giving you.
A bit more, and it disappears. It's magic. Now you see it. Now you don't. Okay? Now you see it. Now you don't. Amazing. What's going on? Well, I find this absolutely fascinating. I couldn't believe this was going to work for us. But
okay, now he could have just given the explanation, but okay, now he moves to another example using a radar gun instead, which is okay, I suppose, but you know, it's not exactly the same thing.
I'll show you another set of equipment over here, which is some microwaves. This is a microwave generator, and it will generate waves which are polarized in one particular direction. And here is a receiver which will receive them. This wave has a wavelength which is 3 centimeters. Now 3 centimeters is about yay long, whereas the light wave is 60,000 times smaller. So if I set up travelling waves coming out of here and ending up over here and not being reflected.
So the only part of this, like I said, I would disagree with, is it has nothing to do with traveling waves. Okay, nothing. There's no waves involved. There's radiation at a frequency.
And it'll be a bit simpler. So I'll detect this by turning this on and getting a very nice big signal. Now I pick up a sheet of...
Yeah, it wasn't that big. If you noticed, it was 5.
Polaroid. This is my sheet of Polaroid. It's just long conducting wires, the same as were in those sheets of Polaroid, but you couldn't see them there. So now I put it in this way round, and you see that you don't get any signals, and I turn it around, and I get a huge signal on the meter at the back. So there it is, nothing gets through, and I turn it around slowly, and you suddenly see the signal appear, and when it's perpendicular, I get a really big signal on the screen over there. Yeah,
I don't know exactly how his signaling thing is working, frankly. But obviously you shouldn't get as strong a signal when there's no filter. There should be some degrade in the signal. So obviously it's not a very precise instrument he's using. But that's, you know, doesn't really matter. But there is another point to make.
What's happening here is that this is sending out waves which are oscillating with an electric field that goes up and down.
Okay, so he has no idea which way the waves are going, actually. They don't know. They don't know whether they're going this way or they're going this way. They really don't know the polarization. They're just surmising it. And his surmise is completely opposite my surmise.
This direction. And as the electric field hits this conducting wire, it induces a current in here, and because of the resistance of the wire, this causes the electromagnetic...
Okay, so just imagine, so as you can see, the grating has smaller bars than it has gaps. So the bars are smaller than the width of the gaps. So intuitively you could argue that why would that stop most of the waves? Most of the waves won't be hitting the bars, the metal bits. Most of the waves will go right through. So how could that possibly be blocking all of the light? All of it. Because it's all polarized in one direction. So the only way it can be blocking it all is there has to be some other explanation.
Wave to be absorbed and heat to occur in the wire. So it's totally absorbed by the wire. If I turn it around this way, well, now the electric field causes a little bit of current to go across there, but then it hits the other side of the wire, and it doesn't dissipate any energy, just gets stored there as a capacitor.
Right, so the argument is somehow these waves aren't standing waves, and essentially when you're projecting them with a filter that's in sync, I mean a wave generator. So with a wave generator, they're pretty much going to be standing waves, and if they were hitting the bars, they would just keep hitting the bars. There would be no moving out of phase to not hit the bars. So you'd have exactly the same problem. Now my theory is that there's electrons between those pieces of metal going straight across, and that what's really happening is the light is being diffracted mostly. So if you put your detector higher, you'd be able to detect a signal, or if you put it lower, you'd detect a signal. It's not blocking all of the radiation.
So this does not absorb nearly as much energy, and so I get quite a large signal. And then I turn it round, there I get virtually nothing. Now I want to turn this around to show you that they're completely polarized oppositely. So if I have that vertically, this is now giving an electromagnetic wave which is oscillating vertically. This is now detecting only those waves which are going horizontally. It's just like those two.
Right. Now again, but the detector is just like the filtering bit, in the sense that the detector will accept anything a little off. So it'll accept those things that are 22 degrees not perfectly straight as straight. So the detector is doing the same thing the polarizing film is. It's not as specific as he implied it to be.
It's a Polaroid there. So I have a wave which is coming out and oscillating this way, and this one is not tuned to detect it at all, so I get no signal. Now I put the sheet of Polaroid in, and there's nothing there. If I turn it to 45 degrees, I get a huge signal there.
Now, huge, see, it actually stays pretty big. And part of that is because of this whole diffraction argument, that when the two-slit experiment demonstrates that light gets spread. And what's happening is the light that had no chance of getting hit by the other receiver, that is the light when it leaves the transmitter, it's diverging. And there's a bunch of signal that wasn't going to be able to get to the other transducer, but it can now because he put that film in there. Because now the film is almost going to act like a mirror, and it's going to reflect some signal back into the other detector.
If I now turn it around to perpendicular, I get nothing. So I'll start off vertical.
So the test would have been to move his detector from left to right and see if there was more or less signal at different angles. Because what that filter is doing is it's not only absorbing some of the radiation, the little metal bits are absorbing it, but it's also deflecting a bunch of signal. So it's scattering the signal, and that's why this signal is not detectable.
In there, I turn it round, I get a lovely big fat signal coming about 45 degrees, and then when it goes further around, it goes away to 0. So something is happening if I put this in at 45 degrees. Right,
so the simple explanation is the stuff's coming out of the filter this way, out of the producer. It's not perfectly polarized. And even if it was perfect, even if you could produce perfectly consistent and there was no fluctuation, it goes to the filter gives it a 22-degree nudge. Okay, so now its center is this. So, and then the next, when it gets to the receiver's accepting anything that's this. So it's always an overlap, and so theoretically it should be 1/4 of the signal. Now, obviously he's reading a lot more than a quarter signal, which he doesn't explain.
I'm able to get waves which are oscillating this way to go through here and be detected by something which is detecting waves that way. I'm changing this signal which is oscillating this way.
Okay, there's the word. I'm changing this signal. So did Daftloday hear that? It's right in print here. Okay, it's right there, right in the black bar there. I'm changing this signal, which is oscillating this way. So my argument would be, no, it's just polarized that way. It's not oscillating. But it doesn't matter. That's just semantics. Oscillating or polarized in a direction. We both agree that it has a geometric polarization.
The one that's oscillating that way, otherwise nothing would go through. Well, I haven't done it. It's this sheet of Polaroid that's done it.
So again, he's pointed out this sheet of Polaroid, this filter, is changing the polarization. It's not just filtering, it's changing it.
So imagine this is a wave which is coming out and has a vertical polarization like this. I can think of that as partly this angle, this side of the set square, plus that one. So as I put it in at this angle, if I think of this as being vertically polarized up and down, it's partly this and partly that. So as I put that in there, the bit which is running this way along this wire is killed off, and the bit which is running that way is now allowed to continue.
And you could argue exactly the opposite, which one was allowed to continue and which one wasn't. But that's exactly the same thing, in just using a different method of geometry. But it's basically just this 45 degrees, 22.5 on either side.
So I have a state which is oscillating this way now. And this thing
so he pointed it out. He said it's oscillating this way, which means it's not oscillating the same way the filter is oscillating, is shaped, but that the range is in this direction, plus and minus 22 degrees on either side.
Managed to turn the plane of polarization of this wave from vertical to this direction.
Now when he says plane of polarization, again, he's not, to be more accurate, he should say the center of the plane of polarization, because the polarizations that are allowed are 22.5 degrees on either side of that plane.
This wave travels along this way, part of that is horizontal and part of that is vertical, and the horizontal part goes in. So I have a wave, I measure it, it changes the state of the system from being vertically polarized to one polarized in this direction. Once I've done that...
So again, he said the word change again, so 3 times he said the word change.
This state can be detected by mass. That's the interpretation of this whole experiment. And that's the classical interpretation in terms of electromagnetic waves. Now, Brady, this is the bit that really is going to do your head in.
Okay, so Brady's going to have his head in because he's going to do some kind of two-slit Copenhagen thing or something.
To enjoy from the tree. Out of this apparatus comes one photon. It is a photon which is oscillating this way. The chances of the photon going through here are 50-50. It can either be going this way or that way, and if I do it 45 degrees there, it's equally probable. Then you get to this detector, and now it's coming out without polarization. The chances of going this way are 50-50. So I only get a quarter of the signal going through if this really works. And that's the explanation why the signal dropped out.
Yeah, so, and obviously his instrument didn't show that, but that's the theory. You know, we're stuck with, he didn't explain why his instrument wasn't showing 1/4 of a signal. But again, it's radar, not light. I don't know why it just doesn't stick with the polarizing film instead of changing the experiment, but whatever.
But notice now, as this photon comes through, I have to talk about probabilities of what goes on.
No, you don't have to do any of that stuff. So again, I don't know why he even brings this up, because it's not really an argument. You don't need to do any of that to understand the filters changing the polarization. There, the problem is solved. None of this quantum crap is at all necessary to understand the mechanism, at all.
It is not deterministic. And if you go through the mathematics...
It's not deterministic. So now this is just stuff he made up. It's clearly deterministic. The probabilities are clearly in a small range of possibilities for each individual photon. They will do one of 4 things, so to speak, and it all depends on their geometry, where they hit the filter. There won't be any magic spaces where magic things happen. No, if it hits the metal, it'll do one kind of thing. If it hits right in between the metal, it's going to do something different. But it's all going to be dependent on where exactly it goes through the filter.
You'll find that these states, which I would like to represent using a ket, which is a triangle like this, and you put the symbol in as a triangle, that ket state changes from one to the other. And in here, in between, I have a mixture of 2 different states, and it's a mixture of these 2 states that allows me to interpret.
Right, so he's just saying he likes to do it that way, the silly way, where he pretends the single photon is in multiple different states, and then he's going to just add them up, all the multiple states it's in, and decide what the hell it was, when all of that's completely unnecessary. Each photon had a trajectory. Each photon either hit the metal, didn't hit the metal, went in between the metal, went close to the metal. Each one had a location, and where the photon was located, where it hit the filter, what position in the filter it hit, will decide its trajectory. You don't need any quantum woo to explain the phenomenon.
So it's much harder for poor old Brady to understand, because somehow quantum mechanics is biting him on the back.
Right, so somehow another physicist says all this stuff is pretty much BS, and that somehow proves how physics has all the right answers is because the physicists don't agree. You know, I mean, he's making this argument to another physicist, right? So I'm just saying, so Daftloday shoring up his argument that they've got the right answer by showing 2 physicists arguing each other about the fundamental theory. So that somehow shows how they have really good evidence, and it's really strong evidence, and they can draw conclusions because they don't agree. I mean, it's, you know, I mean, he's you know, he's just giving me, you know, balls to hit out of the park. I mean, this is just almost too easy.
Sorry, yeah, and he really doesn't like me to talk about mathematics at all. But without that, without the idea of splitting...
Yeah, no, we don't need any of that at all. Just the simple understanding, oh, okay, the filter allows, the jail bar analogy. I can throw frisbees at the jail bars. And the idea is that, look, they're not really hitting the bars, but this is just an analogy. But you can get the idea that a frisbee could be offline where it wasn't going to quite go through the bars, but it slides through. And when it slides through, it lines up straight. So it gets conformed. It conforms to the filter. It doesn't get blocked explicitly. And the photons could be analogized to doing the same thing, that the ones going through the field of electrons in the empty space, depending on where they go through that field of electrons, will get reoriented stronger or weaker based on how close to one of those metal bars they go through.
Listen to 2 different states added together. I have no explanation for what's going on.
So he says he has no explanation if he doesn't make up some theory about how the photon doesn't know what it's doing, doesn't know where it is. It creates a ghost copy of itself and maybe 3 or 4 copies of itself of probability waves, and then those probability waves flight through the atmosphere, and then somehow they combine into an end result. And he can't understand it without that woo. Well, I can, and I think rational people can.
Get your head around that, Freddie.
Yeah, shove that up your, woo-woo.
How sunglasses work out? Sunglasses work, well, I haven't got them, but I used to have clip-on Polaroids, and somehow, if you're looking at light which is reflected...
Well, this is kind of really dumb, so who the hell cares? I mean, we all know that one already. Yeah, they work because they filter the light, the glare light, because the sun is sending, it's only one polarization that reflects off of surfaces. Not difficult. Anyway, what am I doing? Okay, I'll get rid of that video, and that should take us back to this one. Alright, so we did polarization. Let's do mass, I guess. Well, let's do this other one, because, mass could be a whole separate subject by itself, and we'll see how long this one goes.
I want to talk about transmission of waves through the interface between glass and air, for example. So if you have a laser, and my friend George has made this nice little laser.
Okay, so it's the subject through transitions. So this isn't talking about the speed of light through a medium. This isn't talking about how does light get from one end of a piece of glass to another end. This is talking about what happens in transitions between one medium and another medium. So when you have different refractive indexes, that's what this is. So Daftloday didn't have the right subject.
He's made this nice little laser, and I shine it on this face of the prism. It bounces out and comes in this direction. The light is coming down here, hitting this face of the prism, going through and hitting this face of the prism, and bouncing off and coming this way. It doesn't want to go through. It's totally internally reflective. Oh, so it seems.
Okay, now let's understand that the surfaces are what's going to dictate how something reacts. So when light's going through, transitioning through glass, it's already kind of known because of the way how lenses work and everything else that the surface angles are really important. Where it goes in the surface will change its direction, and where it leaves it's going to get its direction changed. That's where all the action is. The rest of it's sort of a straight line through the medium, and it transitions through the medium at this slower speed. Now, I don't know if anybody's ever calculated the internal time, the time inside the glass versus the time of transition. I mean, maybe all the delay, well, it can't be, because then they would know that they could have a really thick piece of glass and it would go just as fast. So obviously the delay in the amount of time it takes light to get through the glass is a function of the glass transmitting the light, and that the surface phenomenon of diffraction is not the same phenomenon. It's operating on different rules. I would argue the rule is this. It's kind of simple, that the external surface of all material things is not some kind of flat thing. It's not just flat, smooth stuff. It's covered in electrons and protons, and the geometry of those electrons and protons is incredibly important to what's going to happen when the light goes in, and how it's going to be able to be transmitted through the force pressure between the electrons. The electrons are all bound between all the atoms. They're all in a tight tension circumstance. Everything's under tension. So you can think of it as being tied with rubber bands. You can think of it as little magnets all tied in tension. So you can't move one without jiggling everything else. And that's the circumstance. So once we understand that's the circumstance, and that the outside of all these surfaces have electrons, free electrons, floating about them. Some a lot more than others, but they all have them. And those external electrons, in my opinion, are what's going to decide fundamentally how light gets to the glass and how light leaves the glass.
If we put another prism close to it, I can make something which looks like a rhomboid shape, and then if there were no gap between these two, you might imagine that the thing would come out the other side.
Alright, so you can't see that very well, but it's just two triangular prisms. Okay, so this one has a flat side, this one has a flat side, and he's put the two together, and now he's going to have to fill that medium with some mechanism to allow the light to transmit through it, because it's not going to do it through air, because air doesn't create any, air's not conductive enough. Okay, so the low conductivity of air means essentially that there are free electrons on one side of the one prism, free electrons on the other side of the prism, and the two electrical surfaces haven't combined. So there's no way for the light to be able to travel consistently to hit surfaces and reflect.
I can't get those to stick together, so at this stage I'm going to get a little bit of water and make a little seal in between the two.
So this is the irony, that he doesn't even realize what he's doing, but he's actually just making it a conductor now. He's making the two surfaces conductive. That is, the flow of electrons between the two prisms will now be in tension. So now you can transmit light through that medium because they're now under tension.
So that the light, which can't get across this air gap, can get through to the other side. So if I squeeze those together and put the water in
There, you saw it. You saw the light go through now, because now it's a conductor. Now the electrons on one surface of the prism are connected to the electrons on the other surface of the prism, and because those electrons are connected, now the light will travel that path instead of reflecting off the external surface of the prism.
So you get complete transmission. So I would like
So good word, transmission. You get complete transmission. And that's what a conductor does. It allows you to transmit electrical pressure, that is, pressure between electrons. So the electrons become connected to each other by the force, and now when you jiggle one electron, you jiggle the electrons in the other prism.
to show you that thing on a larger scale, so you can get a picture of what's going on when the wave comes up to this interface and bounces off. So now I'm going to do the same thing.
So now he's using the microwaves again. Interesting experiment, but again, another one where you really have to be careful how you dissect this, because people could misunderstand what's actually happening.
With microwaves, this is 3 centimeter radiation, so it's about so long, and the waves are quite large scale. This is a generator of these microwaves, and this is a detector which I've hooked up to go to a meter. This is a prism. This is a prism, but it's made of paraffin wax. Metal beads of paraffin wax, yeah.
Okay, so the thing to understand here is the cardboard is irrelevant. So don't even think about the cardboard, and just think of the prism being just made out of the wax. So the cardboard is irrelevant, and what you're really just talking about is the wax.
You know, it gets everywhere on your hands. This is acting as something...
So let's just say the microwaves go right through the cardboard as if it wasn't there. But they can't go right through the paraffin wax. The paraffin wax is like, to light, the glass is to light, the paraffin wax is to the radar. And the radar will go transmit through it, but it's going to reflect off the internal surface of the external surface, just like a prism.
Which is transparent to this microwave radiation, just like this prism is transparent to the laser light coming out of there. And because the size is so small, the microwaves think of this as a continuous medium. It doesn't see it as individual grains, it's just a continuum. But it's extremely strange, and George has manufactured this prism.
Alright, so the reason why it's not extremely strange is because the microwaves have a 3 centimeter frequency. And which that means is that when it's jiggling electrons, it's jiggling them at a much longer length, let's say time interval, and that longer time interval means that you can fill a larger gap. So the microwaves are able to cross bigger gaps than the smaller radiation. So the smaller the gap in the radiation, the harder it is to have a transmission medium in the sense of going from one medium to another, because they can't jump as big a gap. But the radar, the microwaves can jump a bigger gap. So the two wax prisms won't have to be as close to each other, and they won't have to be smashed into being conductive because of the length of time in terms of how they're manipulating the electrons.
Out of bits of stick back plastic and cardboard. And now you can see that this microwave comes in.
So look how close. He's also got the two things very close to each other, so obviously the signal gets degraded quite a bit trying to go through the wax. So the wax isn't really a perfect, it's not like a prism, it's not really clear glass, it's dirty glass, you could say. So it's obviously not as good an experiment. So again, I don't know why he's switching mediums again.
Hits this surface, bounces off, as though it's a ping pong ball bouncing off a wall, goes to here and actually gets straight through. And there is a reading on here.
Right, so that's exactly like before. He's measuring, the light goes this way, and he's measuring the angle that it reflects at, and that he's going to move the other box close, and he's going to change the angle that it reflects, because the two will now be affecting each other. The electrons between the two surfaces will now be interactive.
And you and there'll be a reading on the other one, showing you that a lot of the wave is reflected. And because a lot of the wave is reflected, this is total reflection of the wave. There's nothing coming out there. So I'll just shove this in place, which I've lined up. So this wave, notionally, would come through here, hit this face, and go through there. But it's not. Now I'm going to do something amazing. I'm going to bring the second prism together, bit by bit by bit by bit by bit. And when it gets to about there, you start to get a reading on here and on the other meter. So as I bring it in, suddenly it goes up. Can you see that, Brady?
All right, so you can, the idea would be is that these surfaces have more static, okay, and you can sort of understand it. Candle wax is like that, actually. It does collect charge. And it might even be the cardboard could be helping in terms of once you pass radar through the cardboard that you create a bit of a static charge in the cardboard. But you can understand just looking at it that you could understand that there's going to be a lot more static electricity in this experiment than there would be in two glass prisms, okay, two insulators. These aren't insulators entirely, and they're really good at holding static charge. So now the static electricity between those two boxes is now interacting, which is going to create the ability to transmit the radar out the other surface. It's now going to transmit across the medium because the medium is now electrically active, and the two prisms are now connected to each other by a conductor, and they're not insulated from each other. They're conductive because the static charge is connecting the two together.
And I'm bringing it in, inching it in, and you get a nice signal coming through. So what's happening here is the wave is coming out, hitting this surface, going through this paraffin wax, going through this little bit of cardboard, the air gap I have, and being detected on the other side. And then it's going straight through into the detector.
when that was there,
yeah,
almost everything was bouncing out this way.
Yeah.
And yet when you move that in,
you change
it started going through. Why? What's the angle got to do with this?
Well, the angle, in this case, this angle is such that you cannot find a propagating wave that goes through here that satisfies the boundary conditions. But when I move this in...
There's no satisfies the boundaries. There's nothing to do with that. It just merely has to do with having a continuous medium. Essentially, when you move the two things next to each other, you make them a continuous medium in the sense that you electrically connect them. If you stuck an insulator between them two, like a piece of mica or something, the experiment's over.
You now find that this wave somehow leaks through this region and manages to get into that region without great difficulty.
All right. So where in that video
I want to talk about
was my theory in any jeopardy again? Where did that decisively prove anything about the speed of light and how it moves through materials, how it moves through the medium of glass? It had nothing to do with the subject of actually the transmission of light through transparent mediums, and why through transparent mediums there is it takes time, extra time for the light to get through the medium. It wasn't even on that subject, for fuck's sake. So again, this insane, arrogant, deceptive, false, fake, straw man argument that this video somehow debunked something I have suggested. No, that didn't happen, quite obviously. All right, maybe we'll try to finish.
Fetch me a bag full.
Oh, that's a little nasty. I can't even skip it.
we're going to talk about mass. M is, as with most symbols in physics, gets used for multiple things, but the most common use for M is to refer to the mass of something.
Sorry that I wish I could have the audio. I'm working on this. This is a project in whatever you call it. So I've had some issues with the audio. So this is an experiment again. This video, still trying to work out.
What we don't know about mass is probably more interesting.
M is for mass.
So what we don't understand about mass is more interesting. And okay, so my understanding, as I've explicitly pointed out, what mass is merely collecting bits of force, and as you collect them, that's a piece of mass. So light has a photon of light, or a photon of radar, a photon of radio waves. Every single little force bit of magnetism, they all have a mass of 1. That's what a force bit is. And electrons are a collection of those, and protons are a collection of those, and neutrons are a collection of those. And drawing a picture just for so we have clarification on what we understand to be the truth here. Alright, so these are protons and the electrons, and what they represent is, let's see, that's close enough to not terrible, maybe, I don't know, that over here. Alright, they're 360 degree spheres, so understand, so there's force moving in all three dimensions: up, right, up, down, left, right, forward, back. They're full of a collection of bits. So when they're standing in one place relative to you, as far as you know, they have exactly the same force constituent. So if we're both moving on the planet Earth or doing whatever we're doing, we both might have more arrows going inside of our electrons going this way than arrows going that way. Okay, but the idea would be if we were in a neutral space, completely out in the middle of space, and we actually had zero velocity, we would have completely even distribution inside of all of our electrons and protons. Your electrons and protons would have an equal amount of fish, or force, going in every single direction, and it would be entirely balanced. And there's these slight imbalances that happen because of our environmental circumstances where we've collected more force. Now that's mass. So when we're stationary, when we have absolutely no velocity, we have mass in all directions that's exactly the same. As I start giving you velocity, I'm obviously creating an imbalance in your mass distribution, and now you'll have more mass in one direction than in another. You know, just right, big arrows there. So now you could have more mass going, more arrows are going this way. What the hell is that? Both fingers go the wrong way. Going this way, you know. I guess it's the sync. See, the other problem is the sync of the audio and the video isn't great yet. Now, this computer just really isn't up to doing this, but I'm forcing it to. But anyway, so you get the point. The point is as you are changed by acquiring velocity, and you are physically changed, every one of your little bits changes in terms of it goes from being neutral to being skewed in a direction. So now it has more mass bits, more force bits in one direction than the other direction. It has a bias, a mass bias. But its total number is still the same. It still has the same amount of energy inside of it, still has the same amount of mass inside of it. It's just that now it has more mass in the direction it's going and less mass in the direction it's not going. And that sort of works for how you understand the world. The bullet that hits you in the head going 10,000 miles an hour, it obviously has a lot more mass in the direction it's going than in the direction it's not going. The direction it's not going, you won't feel a thing. The guy who fired the gun isn't going to feel a thing. Anyway. Continue. Well, except obviously the equal but opposite, you know, but it's not going to be in his head, and it's going to be distributed over a longer period of time. How do I get this video to play? Go back here.
So I got a nice sphere, which is a Chinese metal ball for relaxing me, and this weighs, as I put it in the scales, 140 grams, as you can see. It's a complicated concept to explain, but mass has two effects, two things that mass is all. And this is what people normally mean by mass. Solid object is really heavy and compact. But the dictionary says that there are two different definitions according to Taylor's. One is gravity. The more massive an object is, the stronger its pull of gravity is. This is the mass which acts downwards, pulling this towards the Earth. Alright,
it's not that its pull of gravity isn't stronger the more massive. The more massive it is, it's just that it's collected, just because it has more elements to it. It needs more gravity to move it, so to speak. It collected more force. The heavier it is, the more force it collects to move, which means when it hits you, it has a lot more force in it, and that extra force is what you're going to feel. I mean, if I took all the energy from a space shuttle and pushed a grain of dust with it, or I push the space shuttle with it, frankly, it's not going to make a difference, in the sense that the dust particle is going to go so much faster because the force isn't going to be used up trying to push all that heavy matter. So the end result is just the force hitting you. So you'll either get hit with a dust particle going insanely fast, or you get hit with the space shuttle going a lot slower. But the end effect of how much distributed energy is going to be, it'll be the same as long as there isn't some other waste equation.
And if it's a heavier object, that means it has more mass, or if I put on weight, as I stand on the scales, I weigh more. This is a smaller mass, which came from the red nose day a few years ago, and you put that on there and it hardly moves, and I weigh it, it's about 5 grams. So you can actually measure the difference between these two quantities. And the other is how much something doesn't like being pushed around. So if you've got something that has a very high mass, it really doesn't like being, you have to push it very hard for it to move at all. Now
So gravity is really good at measuring relative masses. Okay, so you will find a difference. You can always use gravity to say what's the atomic weight of something, and gravity will tell you that based on a volume number, and it's pretty reliable, and it'll give you relative comparisons. It's not giving you an absolute mass distribution. It's just saying that obviously if this pen is going up, if I give it force arrows going in a direction, and so I'm comparing two things that don't have the same distribution, so I actually push one in a direction, you can understand it's going to weigh a lot less if I give it a boost through gravity against gravity, and if the other one's being measured just on gravity. So I put a little flea-sized rocket engine on here that just barely gives it a little bit of boost. It's going to weigh less. So your measuring device isn't going to be accurate anymore, because that little bit of energy is going to distort your understanding of what's really happening. But it's really all about the little bits and what direction they're moving. So as long as two things have a bias in the same direction, you can make relative comparisons. But when they don't have the same bias, when you're giving one a different bias, all of a sudden your weight measurements aren't going to accurately reflect mass.
Another aspect of the mass, according to my version of Chambers' dictionary, and that is its reluctance to move. If something has a very low mass, then it's very easy to make it move. So if I put these objects...
Okay, so this idea that it has something to do with making it move is wrong-headed, in the sense that you're really arguing about how hard it is to how much energy has to be distributed over how much volume. So the heavier it is, there's more volume that has to be given the bias. You have to change the more atoms and more protons and more electrons, and neutrons. You have to change all of their bias. So the more of them there are, yes, that's more work. So there's more work that has to be done to make it start rolling or something. So two objects of exactly the same weight can have a resistance to movement. Well, that's not a resistance to movement. It's not resisting moving. The simple truth is it takes more force because there's more matter. There's more bits that have to be converted. You can't convert the same number of bits. It's like the rocket engine thing. It just makes, you can logically understand. If there's more to move, it's going to take more energy to move it at the same speed. You're not going to be able to make the two things go the same speed if they have more mass. But there's no resistance to movement.
Here, and try to measure how reluctant this object is to move. I can flick that, and I'll do this with full vigor, and it really moves. You see that?
Yeah, because and it moves so easily because it was a tiny number of a tiny amount of atomic weight between those two things. The sponge ball has a tiny atomic weight, total atomic weight, than the metal ball by a factor of maybe 1,000,000. Huge difference in their atomic weight. How many little bits have to be converted? And so the simple equation is this little finger movement isn't going to be enough to get that steel ball nearly as excited as you can get the foam ball, because you have so much more energy hitting each one of the atoms. Each atom is getting hit by a ton more energy in the foam ball than in the steel ball. But it has nothing to do with any resistance to movement.
So one of the great unknowns of physics, one of the great unexplained things of physics, is why mass both of these things. And it's basically you can use the same number to explain both how strong...
Right, so this is the point where it's just so ironic, because they're the physicists who don't have the answer. I'm the physicist that does. And the answer is simple. Okay? The matter bits have force in 3 dimensions. The force bits only move in 1 dimension. So until force acts on the matter bit and changes its bias of what it contains, that changes its mass, essentially, its mass distribution. Again, you don't change the mass of the space shuttle by moving in a direction. What you change is the distribution of its mass. It now has more mass in the direction that it's moving, and that's why it has more impact. If it crashes into something, it crashes into it as if, wow, it's really, really heavy in that direction. And it's really light in the opposite direction, obviously. And in the perpendicular dimensions, you can understand it just from your own ability to see something moving very fast. If something's moving very fast, you barely get a glimmer of it, because the light's not reflecting off nearly as much stuff, because there isn't stuff to reflect off of. You're getting tiny number of photons back because there's no mass to reflect the light off of. The mass is gone. Fuck's sake.
Gravitational pull is, and also how much it doesn't like being pushed around. And I'll do it with this one, with the same figure, although I'm very reluctant to, because I don't. And you can see that it moves, but it's more reluctant to move and doesn't go with the same speed. In fact, it hurt my hand. That is called the inertia of the object, and it's the inertial mass of the object. It's the reluctance to move. In the dictionary, it's the resistance.
Okay, so resistance and reluctance are just kind of fake words. It has nothing to do with the real circumstance. This isn't about friction or some other kind of thing. This is just about making the energy having an effect, and the way the energy has an effect is that it transmits through all of the mass of the object, all of the amount of these little force things, these little arrows. If it has more arrows, you need more force to bend them. Okay, if you got a school of fish, you got 1,000 fish in the school, and you want to change its direction. Well, if you send one fish in to hit some other fishes and change their direction, it could take years for it to get through 1,000 fish and change all their directions. Not years, but you know, it would take a very long time for if you gave it enough time. But these are not timed equations. These are equations of it's got to react now. The force moves. And so you can just understand that if I send 10 fish in, then I have some chance of moving 1,000 fish. But one fish, less chance. 100 fish, even more chance. It's just about how much force you apply, not the resistance. There's no resistance to change.
I prefer to think of the object as wanting to stay still, to be inert, and it wants to stay where it is. So those are the aspects of mass that we know about, right from our childhood. But the really fundamental question that hasn't arisen is what causes mass? That's, again, you're venturing into very deep water, I have to say.
Right, and it's not deep at all. It's really simple. The mass is made up of a three-dimensional force, and when you change the orientation of the three, and when you change the balance of that force contained, you create velocity. There, solved, simply, easily.
If you really want to answer that question, you have to ask the particle physicists, because they're people who really understand.
Yeah, no, they don't understand shit.
As far as I'm concerned, it's just the property that the object has, and we're quite happy to accept this.
Okay, we're quite happy to accept. So this is Daftloaday's great argument against my physics. This wishy-washy, we're just happy to accept. We don't bother asking any hard questions. We don't have an answer. We just let the particle physics guy make up some bullshit and we'll say yes to it. So he's demonstrating how his physics has some sort of integrity, some sort of rock solidness, and look at these wishy-washy bullshit answers to these fucking simple, rock-bottom, fundamental questions. They can't even explain why something goddamn moves, for fuck's sake, and yet he'll ridicule me when I have explained why it moves with a simple, rational, reasonable, goddamn logical model. What a goddamn cunt.
That the Large Hadron Collider might answer if it uncovers the Higgs boson, which is a big particle that we think might be involved with making objects actually have mass, but nobody has actually seen it.
What is the origin of
So now they're going to talk about the Higgs boson. So this is his argument to me. He says the Higgs boson is the reality. Higgs boson is the strongest. We know this is a fact. This gives things reality. You don't have mass. You don't have reality. You don't have substance unless the Higgs boson gives it to you. You're an ugly sucker and you can't interact in the universe. You know, the Higgs boson hates dark matter. Is that the logic? Oh, that's right, Higgs bosons must love matter, but to give it dark matter, but it gives it mass, but it doesn't give it anything else, not a single other property that matter has somehow. I mean, this is his fucking argument to me, this complete crap. Fucking Higgs boson this is a proven fact? Fuck you.
the mass of because there is no, there is a theory, but the theory hasn't been properly tested, so it's still a hypothesis. There's a theory due to Peter Higgs of Edinburgh that says there's a huge field throughout the universe, permeating everywhere, with a particle associated called the Higgs boson, and it is the presence of this field coupling to each particle.
Ether. This is just ether theory. We don't have an answer. God did it. Make up some fake bullshit zone that has all the power. It's doing all the interesting stuff. The bullshit zone. The fucking, I'm too stupid. I have no imagination. I can't come up with a rational answer. So, yes, the bullshitter did it. Mr. Bullshit did it. The invisible bullshit man. I mean, this is just such crap as fucking goddamn science. Yeah, I do. I know it's crap.
People have asked this question. William Waldegrave said years ago, it must be more because he was in the Conservative government, that he would give a prize to the best explanation of what a Higgs boson was. And the winning answer, or something like the winning answer, was that imagine you go into a cocktail party and you're very attractive, so you found a £10 note, and you say, I've just found £10, who dropped it? Everybody would come rushing towards you. And then if you tried to move through the party, you would be surrounded by people and find it very difficult to move. Whereas if you came in and...
Okay, so this is their explanation, that somehow these matter bits, these electrons and protons, there has to be a little Higgsy that sticks to them, says, I'm a winner, I'm cool, like Trump or something. You know, and they just proclaim somehow, now I'm real. I wasn't real before until Mr. Higgs came over here and stuck to me like a little $10 bill, and so now I'm attractive. That's their bullshit explanation. So you got dark matter, dark energy, fucking Heisenberg, you got Huygens, and now you got this crap, which is, you know, I'm only real if, you know, the Higgs sticks to me. I mean, what a pile of crap!
Say that I've just lost £10. Has anybody found it? You'll find everybody move away from you, and that will be an anti-Higgs boson. So
Anti-Higgs boson. So look what they've done. They've taken a simple concept like charge, you know, the repulsion and the attraction which is the non-repulsion, all right? It's a pressure gradient, right? There's no such thing as attraction. There's just more pressure on the other side of the fucking door, and the door hits you in the face because there's more pressure on the other side. The door wasn't attracted to you. It was repulsed by the pressure. All right, and that's the only mechanism in this goddamn universe, and these idiots have no fucking clue. And how do they post this? I'm supposed to be taught by them. They're teaching me reality with this fucking bullshit, the anti-Higgs. The anti-Higgs. The magical, we just made it the fuck up. We certainly never saw one of those. But if there's a positive Higgs, there must be a negative Higgs. I mean, they're just making this crap up, and it's shit. I mean, if this was brilliant, you'd say, okay, what a cool pile of made-up crap. But this is shit.
A creaking mass to you because you are attracted in some way, just as a £10 note would be attractive. And so you find it difficult to move, and it's your reluctance to move that causing people trusting around you, which is a simple mental picture I have.
Well,
It
it's
sucks.
we don't use the most sensible units for measuring that. So in truth, sometimes we talk about measuring things like the mass of the sun in grams or kilograms, which gets into very, very large numbers.
And when everything in astronomy, the numbers get so big that they can't completely mean it. So,
Yeah, exactly, because there's so many electrons, so many protons, so many neutrons inside of the sun. So yes, the atomic weight of the sun is goddamn gigantic. So what? That's certainly not an argument.
Well, the Large Hadron Collider is meant to be working with energies such that they will be able to detect the Higgs boson if it's there. The energy range covers it, but then unfortunately, as soon as they've got it up and running, the helium holds a huge amount of damage, and it's gone that way.
Right, so after the $32 billion they spent on it or whatever, they finally found their Higgs and found in some way that no other human could ever understand the findingness. The findingness is veiled in 5 zillion fucking equations and a bunch of fucking beep 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 data and bullshit. There's no fucking picture of the fucking Higgs. There's not even a picture of like a note it left behind, like it slept on your couch and it left a bump in it or something. They'd have nothing. This is just made up crap.
In my line of work, I'm talking about massive galaxies or even clusters of galaxies. And these are some of the largest objects that we know about in the whole universe.
So what you can do, you have to measure things not in kilograms, but actually in units that are kind of more...
Yeah, but they're not really objects, quote unquote, right? I mean, they're made up of the objects that are actually doing the mass equations. They're mostly empty space. So again, you always have to go back to the electrons, the protons, and the neutrons. The whole universe is nuclear. There's nothing else moving. The only thing moving is the force bits. And that's it. That's it. Everything else moves because the force bits push them somewhere. That's it. Pressurized. That's it. There's nothing else happening. It's all nuclear physics. There is no other physics.
With the things we're interested in. So, for example, the main mass unit that astronomers use is the solar mass, the mass of the sun. And that's kind of a useful number because, for example, if you figure out that some galaxy weighs 10 billion times the mass of the sun, that immediately gives you a feeling that it's probably an object that's probably got about 10 billion stars like the sun.
Even then.
Right. Spread out by incredible amounts of fucking distance. So it is so insanely huge, 100,000 light years across, that the total mass by distribution, okay, is lighter than a piece of dust. So if you talk about it by volume, mass per volume, its mass per volume is dust.
It's so small compared to these large numbers that you have to talk in terms of billions or thousands of billions or millions of times the mass of the sun.
I grew up in the 50s and 60s, and then we all had imperial units, and so I had to learn Ukrainian.
All right, well, this is totally, they're just talking about, you know, I'll prove it. I mean, she's still going to be talking about pounds and...
They don't actually use anything much heavier than the mass of the sun. Occasionally people kind of use the typical mass of the galaxy.
Yeah, sometimes they use special words like piggly wiggly and ziggly diggly. You know, just say 5 galaxies worth is a piggly wiggly. Who cares? I mean, I don't know why they, you know, they should have spent more time on the physics and less time on the rubbish. Let's talk about, you know, pounds versus ounces or something. It's just bullshit. So anyway, totally debunked 360 symbols videos, in my opinion. Totally debunked fucking Daftloday bullshit accusation that there's some kind of good physics here, reliable physics, like they somehow have a clear model, a good model, a reliable model, a rational model. The first video, the guy is actually arguing with another physicist over the fundamental principles involved. I mean, clearly they don't know what they're talking about. They have no fucking ton of evidence. They have very weak evidence. They're just speculating all over the damn place, and they're speculating with a model that's fundamentally wrong. It's too complicated. It's fucked up. It doesn't have anything. It doesn't get to the real root of it. It doesn't. They don't. They're fucking physicists, and they don't understand. It's fucking all of it's nuclear physics. It's all about electrons, protons, and neutrons. They're the only matter bits, and the only force bits are force bits, and they're all the same. The gravity, the magnetism, the electricity, the nuclear forces, it's all about force bits moving matter bits. And that's all there is in the damn fucking universe. And so you haven't debunked me at all, you pretentious cunt. Alright, all you've done is demonstrate how I don't have any fucking adversary here that has any fucking integrity. You can't make a solid argument. You can't stay on the damn subject, and you make these outrageous accusations that there's some piece of evidence in here, some sentence in this rubbish videos you made me watch, these 3 rubbish videos, that there was some sentence in these videos that proves me wrong. And there wasn't one fucking sentence that came anywhere close to doing that, and 90% of the sentences proved me fucking right. You fucking lying piece of shit. To imply otherwise is lying. Alright, enough. Fuck you.